Assalamu alaikum. In the name of Allah, the most beneficent and the most merciful. Assalamu alaikum. My name is Noor Hussain and my roll number is 19 NTU TE 0145. Today, the topic you assigned to our group is Kinaf fiber, and my partners' name are Sahabaloch and Mukarrab Hassan. Sahabaloch roll number is 19 NTU TE 0150 and Mukarrab Hassan roll number is 19 NTU TE 0140 and my roll number is 19 NTU TE 0145. Of my presentation is about knaf fiber, and my points is that introduction to knaf fiber, origin of knaf fiber, chemical structure and composition of knaf fiber. What is knaf fiber? Knaf is an animal species belonging to the Malvaceae family, characterized by the rapid growth and high biomass and used as a source of multi-purpose fiber. Fiber. Two kinds. The long fiber are mainly in the thin bar, whereas the short fibers are in the lignite core. Structure. The stalk of the knaf plant consists of the two distinct types of fibers. The outer fiber is called bast and comprises roughly 40 cm of the stalk dry height. Weight. Refined blast fiber near 2.6 mm and the similar to the best softwood fiber used to. Composition. Cellulose percentage is from 44 to 55%. Hemicellulose 21%. Lignin is 15 to 19%. Harvesting. Knaf crop are both handed and mechanical harvested. Fibers are usually separated from stalk mechanically, although retting is still done by handing. From some areas, plants are harvested from the stalk from which the fiber is extracted. Retting of knaf fiber. The process by which the fiber got loose and separated from the woody stalk. Jute and knaf fibers have mostly same retting process. Water retting. Plant stems are immersed in water, river, pond and tank. It needed to 7 to 14 days. Washing and drying. Fibers are separating fiber. Properties of knaf fiber. Fiber length is from 2.6 to 4 mm. Diameter is from 17 to 21.9 micron. Density is 1.4 gram. Elongation 1.6 percentage. History. History of knaf fiber. History of knaf fiber is a fiber plant native to East Central Africa, where it has been grown from several thousand years for food and fiber. It is commonly wild plant for tropical and subtropical Africa and Asia. It has been a source of textile fiber from such products as rope, rugs, bagging. Also, knaf is a promising source of the raw material for paper and other fabric products and has been introduced since in China, USSR, Thailand, South Africa, Egypt, Moscow and Cab. Growth habits. Knaf is a member of mallow family with okra and cotton as relatives. Knaf grown in dense standard as largely unbranched and grow to the height of 8 to 14 feet and under certain condition will reach 20 feet. Climate. The canal fiber is said to have a wider range of adaptation to climate and soil than the other fiber plant is commonly commercial production. Knaf yield has been highest in region with high temperature. Soil. Knaf is adapted to the wide range of soil type but performing best as the higher well drained. And my last point is that chemical composition and structure of fiber. Cellulose 66.47, lignin 2.39, hollow cellulose 75.43, hemicellulose 9.43, and extractive 2.11.
Is Sahabaloj and I am a student of National Textile University, Faisalabad. And the topic on which about I have to give the presentation, that is the surface morphology of the Kina fibers from different extraction method. So these are the points that I have already written for you, and I will try my best to explain these points in detail. So first point is main concern. The main concern of my presentation is the surface morphology of the Kina fiber. So because of surface morphology Kina fiber, it depends upon the different extraction method or the different retting processes. So we have also the I have also the little bit touch to these also points. So what is retting process? Retting process, the Kina fiber were processed through the water retting, chemical retting, and mechanical extraction. And after that, the fineness of the fiber. The water retting method produce fine fiber between 3.2 to 3.7 tex, while other methods produces fibers between 4.0 to 5.0 tex. And the chemical retting method resulting is smooth fiber surface when examined using field emission scanning electron microscope under the different magnification. And after that, the kinuf plant. So kinuf plant is, what is the kinuf? Kinuf is the plant in which the cellulose bast fiber category. It is one of the green cellulosic fiber similar to flax, sisal, jute, and other related plants which have served humans for shelter and clothes for a long time. And after that is the cross-section shape of kinef fiber. So cross-section shape of the kinef fiber are evaluation method for multi-cell type natural fiber that is treated in a highly concentrated alkali solution was produced using kinef fibers. Cross-section of kinef fibers were drastically changed by the alkali treatment compared to the untreated fibers. Conventional data-based approximately DBA method for evaluating the cross-section area was not sufficient because it was based on cross-sectional area data of the untreated fibers. So that shape of each in the alkali treated fellows was in that was the shape is ellipse, and the again crosslet with the hexagonal cross-sectional area, which was approximately by measuring the project winds on the along 0° to 60° and 120° direction. This is the new database approximately method. Results showed that the tensile strength was greatly improved compared to the strength various and estimated by untreated fiber based DBA. And the point is the fiber diameter. The fiber diameter from the different retting and extraction methods vary from 33 to 134 centimeter and did not show to have any relationship with fiber fineness. Nowadays, a natural fiber has become the attention in the many product development efforts as the people have become more aware in the safeguard and the environment and to reduce the cost. The focus is to use natural fiber as an industrial material such as for the sports equipments and automobile industries and construction industries, and the material for physical and non-physical elements. The demand for the natural and natural fiber based products have rapidly increased in recent years, is expected to show a growing trend in the future. And next is the quality of fiber. The quality of fiber is determined by the end part of the fiber processing, especially fiber extraction called retting process. These are the several types of retting process commonly being practiced in the industry. The resultant fiber composition after the retting process, such as lignin, pectine, will determine the surface and the morphology of the fiber. So we have to know that what is the retting processes. First of all is water retting process. Water retting process, fiber retting and extraction were conducted with the assistance of the nature fiber industries. Keener fiber of 4 months old were harvested before being treated using water retting process, chemical retting process, and mechanical and extraction process. So the water retting process, the keener fiber were immersed in the stored in a water tank for 10 days, and the chemical retting process use a small percentage of sodium hydroxide and sample were left in the solution for 2 hours at 16 degrees centigrade. And the next is mechanical extraction or mechanical retting process. The mechanical extraction was conducted using a decorated machine to mechanically pull out the outer part of the stem from the core. In addition, some fiber were made to undergo an additional process is called the cording. So the effects of the retting process on the keener fiber, that is based from these facts. It is therefore the understand to retting fiber and extraction process which will give greater influence in the keener fiber properties, especially for the use in textile industries and textile related application. The retting process of parameter will affect the fiber strength. Studied on a high level that found keener fiber from water retting and higher tensile strength in compare with other retting methods. However, some aspects of the fiber preparation such as fiber fineness have not been highlighted yet. Fiber formation techniques. So because of keener fiber is a natural fiber, so we can declare that this is the man-made fiber. So I have written a conventional way of formation techniques. So first point is the production, processing and cultivation of fiber. So that is, it is shown from May to October growing quickly, rising to height of 5 to 6 meter in a 6 to 8 months, and temperature needed from 20 to 27 degrees centigrade. And the next is harvesting. Enough crop are both hand and machine harvested. Crop we can harvest by the man. We can't make this fiber to the man-made. So fiber are usually separate from the stalk mechanically, although retting is still done by hand in some areas. Plant are harvested for their stalk from which the fiber is extracted. Retting of keener fiber, the process by which the fiber got loosened and separated from the woody stalk. Jute and keener fiber have almost same retting process. Water retting, plant stem are immersed in a water, river, ponds and tag. It needs 7 to 14 days as we have discussed the previous slide. And last point is washing and dyeing. Fiber are separating with the water, different sides of. So fiber grows at a different stages. First stage is the seed and the seed capsules. So a pointed and a wide seed capsule is formed that is about 1.9 to 2.5 centimeter long and 1.3 to 1.9 centimeter in diameter. The seed capsules are covered with the many small, fine, loosely held, hairy structures that are very irritating when in contact with the human skin. Each capsule contains 5 segments with a total 20 to 50 seeds. Capsules. The slat black wedge-shaped keener seeds are approximately 6 millimeter long and 4 millimeter wide, with 35 to 40,000 seeds per kilogram. Once pollinated, the seeds require 4 to 5 weeks to maturation. So the next point is the flowers and the pollination. Next stage is the flower and pollination. So the seed become the flower, and the flower is keep plants produce large, slowly, lightly yellow, creamy colored flowers that are bell shaped and widely open. The flowers of many cultivators have a deep and narrow maroon colored center. The flowers are 8 to 13 cm in diameter with 5 petals and are borne singly in the leaf axis along the stalk in the branches. The complete flowers are intermediately, therefore the plant continues to produce additional flowers. Although the plants are high self-fertile, generally considered self-pollinated, the plants can be cross-pollinated, and the nature of the kind pollen prevent vine dispersal that are very cross-pollination is a consequence of the activity. So the next stage is the leaf. Next stage is leaf. So leaf is the Quinoa plants produce simple leaf with the straight edges on the main stalk and along the branches. The position of these leaves alternate from side to side the stalk and branches. Cultivar and plant age affect the leaf shape. Quinoa plant produce two general leaf types, divided and entirely divided. Such leaf cultivators have deeply loaded leaf with the 3 to 5 and 7 loops per leaf. So the next stage of the fiber growth, that is the cope, that become a corp. So kinef is a highly yielding fiber that can utilize as a raw material in many industrial application, ranging from traditional fabrics, yarn and copes to a new application in building materials, components and lightweight car parts, especially used in the textile related applications.
As my partner Sabroj discussed the parts of canal fiber, so I discuss some properties in the areas of chemical and physical properties and its applications. So first of all, we discuss the physical properties of canal fiber and its comparison with the other fibers. So color. The color of canal fiber is naturally pale or yellow green. Next is tensile strength. The tensile strength of canal fiber is 930 megapascal. Canal fiber is a very strong fiber, and its young modulus is 53 gigapascal. Next is elongation at break. It has an elongation at break 1.6. Specific gravity. The specific gravity of canal fiber is 1.07. Next is moisture gain. Moisture gain. Standard moisture gain is 0.95% in per 24 hours. It has a moisture absorption ability. Next point is density. The density of canal fiber is 1.04 gram per centimeter cube. Crystallinity. Crystallinity of canal fiber is 30 to 31%. The crystallinity depends on the X-ray diffraction. Effect of heat. Due to heat, the certain temperature, the tensile strength and the modulus is increased. For modifying the canal fiber, we heat the canal fiber at the temperature of 140 degrees centigrade. So now we are discussing the canal fiber physical properties with the other fibers. So we placed some properties uh, in the table. So that first column is fibers and next is density. So we see first of all density. When we see that canal fiber has the density 1.04, on the other hand side, Rami has a property that its density is 1.5, which is more than canal fiber, and flax has the density between 1.4 to 1.5, and hemp density has 1.48. And next is that jute has a density between 1.3 to 1.46. Next is sisal. Sisal has the density between 1.33 to 1.5, and cord has the density between sorry has the density is 1.2. And next is cotton. Cotton has the density 1.5 to 1.6. Next is elongation. So we see that the canal fiber has elongation breakpoint 1.6%, and Rami has 2 to 3.8%, Flax has 1.2 to 3.2%, Hemp has 1.6%, Jute has 1.5 to 1.8%. Sisal has 2.0 to 14%. Core has allocation point between 50 to 30%. And cotton has the allocation point between 3 to 10%. Next is that tensile strength. Tensile strength make the fiber strength. Fiber strength basically is a tensile strength. So fibers canal tensile strength is 930 megapascal. In the some articles, we see that canal fiber has the tensile strength between 600 to 1200 megapascal. Next is ramite. Ramite they has the higher strength between 2 220 to between 938, and flax has the tensile strength between 345 to 1500 megapascal. And when we see that the hemp has the tensile strength between 550 to 900 megapascal. And jute has the tensile strength between 400 to 700, sorry, 393 to 800 megapascal. And sisal has the tensile strength between 400 to 700 megapascal. So the strength of core, so the tensile strength of core is between 175 to 220. And cotton has the tensile strength between 287 to 597. As we see that the canal fiber has have a very strong fiber. So next is moisture gain. Canal fiber has a great ability to absorb moisture. So we see that in the column that canal fiber has a moisture gain is 17%, and ramai has 8.5%, flax has 12%, as well as hemp has 12%, and similarly jute has 12%. Sisal has 11%, and core has 13%, and cotton has the 8.5%. So next is that young modulus. The young modulus of Kina fiber is 15 gigapascal. Remai has 44 to 128 gigapascal, and flax has 27.6 to 80 gigapascal, and hemp has 7 gigapascal, 70 gigapascal, and jute has 10 to 30 gigapascal, and sisal has the 9 to 38 gigapascal. Core has 4 to 6 gigapascal, and cotton has the 5.5 to 12.5 gigapascal. So these are the young modulus of the all different fibers. As we see the different physical properties of different fibers in the previous topic, so our next topic is chemical properties of canal fiber and its comparison to other fibers. So first of all, we see the chemical properties of canal fiber. The chemical property of canal fiber are based on the cellulose, hemocellulose, cellulose, and lignin, which are the main components of natural canal fiber. The overall composition of canal fiber are glucagon 31 to 70%, and xylem has 80 to 22%, and lignin 3 to 90%, 19%, and the hemocellulose has 8 to 13%, and waxes has the 0.8%. Next is action, its action with alkali. Here resistance power is good. Alkali is small amount does not damage. Alkaline small amount does not damage the canal fiber. Action with acid. Strong acid damage the fibers such as hydrochloric acid or sulfuric acid, concentrated sulfuric acid, and damage the fiber. But weak acid does not damage the fiber. It had a good resistance. Now we are discuss the chemical properties which are based on cellulose, hemicellulose, lignin, and waxes. So we see in the table that there are some fibers in a column, cellulose in a column, and hemicellulose values in the column, lignin values in the column, and waxes values in the column. So When we see that kenaf fiber has cellulose value between the 45 to 57%, and it varies, such as different types of uh, kenaf fiber like bast or core fiber. So it lies between in them. So next is that we see bamboo cellulose percentage between the 26 to 43%. Banana has the 64%. Core has 31 to 42%, and flax has 70 to 73%, and uh, pineapple 80%, remise 68 to 70%, 76%, sisal is 73%. When we now we see that the hemicellulose percentage in the different fibers in the chemical composition. So kenaf fiber has the hemicellulose percentage is 8 to 13%, and bamboo has 13%, banana has 20%, core has 11 to 20%, and cotton 2%, flax has the 18 to 20%, and jute has the 14%, and rami has 13 to 15%, and sisal is 14%. Now we see the lignin percentage in the different fibers in its chemical composition. Lignin percentage of kenaf fiber is 21.5%, and bamboo has 28%, banana 5%, core 40 to 46%, cotton only 1%, and flax has 2%, hemp 6%, and jute 13%, and rami 1%, sisal is 11%. Now we see that the waxes percentage. Waxy percentage of kenaf fiber is 0.8%. Core is 4%, cotton is 0.4%, flax 6%, and hemp 2%, jute 2%, similarly as sisal 2% and maize 6%. And some ash percentages are also in them. Kenaf fiber has 2 to 5%, and seed flax has 5%, jute has 0.5 to 2%, and hemp has 0.8%. And kenaf fiber has 2 to 4%, which is core fiber, and jute has 0.8%. Kenaf fiber has many uses and applications in the in daily life due to its strength and its properties, such as in gardening, packaging materials, special paper types, production of coats, ropes, bags, and soil-less potting mixes, animal bedding, and engineering wood, insulation of automotive product, and it is used by some man-made fibers, and it make a strong material which is used in automotive product in different areas.